So now we're going to discuss the next section, 1.2, applications of linear and rational equations. These are essentially word problems. So when you attack these word problems, make sure you follow the following problem-solving strategy. You want to read the problem carefully, determine what the problem is asking for, and assign variables to the unknown quantities. It's going to be important for you to write a little sentence, a reference sentence. You know, let x be equal to your unknown quantity. Maybe that is pounds of apples, etc. Then we're going to make an appropriate figure or table, if applicable. Make a graphic organizer, draw a picture, put information in a table, just get organized. You want to make sure and label that information in your table, and also label the variables in the figure or the table. Number 3, you want to write an equation that represents the verbal model. That is our mathematical model. The equation may be a known formula, say from physics, finance, geometry, etc., or it may be one that you create that is unique to the problem. You'll do algebra to solve the equation from step 3, and you want to make sure that your answer is reasonable in the context of the problem. So the first type we're going to see is a problem from finance involving simple interest. When we get into chapter 4, we will be looking at compound interest problems, but for now these are just simple interest. The formula used to calculate interest earned off a loan or investment is the principal times the rate times the time. Here's an example. If $5,000 is invested at 4% simple interest for 18 months, then the amount of simple interest earned off of that investment is calculated by inserting the principal of $5,000. We're going to multiply that by the interest rate of 4%. Now notice anytime we have a percent, we're going to convert that to decimal form, its appropriate decimal form. And then the time has to be time in years. So that's why it's important to put a year and a half versus 18 months. Because the formula I equals principal times rate times time, the time has to be in years. Let's look at our example. Laura borrowed a total of $22,000 from 2 different banks to start a business. One bank charged the equivalent of 4% simple interest and the other charged 5.5% interest. If the total interest after 1 year was $910, determine the amount borrowed from each bank. For these types of problems, I find it helpful to set up a graphic organizer describing kind of what is going on here, okay? We're going to borrow so much from one bank, and they're going to charge us some interest, okay? And then we're going to borrow some more money from another bank, and they're going to charge us interest as well. Now the problem says the total interest after 1 year, this 1 year is the time, but this is the sum of the interest that each bank charges to borrow that money. So I'm going to say the interest plus the interest is 910. Now, the 2 banks charge 2 different interest rates, and so let's label that. The first box will represent the first bank that charges 4%, there's the decimal equivalent of 4% simple interest, and the other charges 5.5% interest, and so its decimal equivalent is 0.055. I like to put percents on the outside, interest rates basically, and then amounts that are borrowed on the inside. That's what we don't know. We don't know how much was borrowed from each bank. She borrowed a total of $22,000, but the question is, how did she split that up? Was it $10,000 and $12,000, $15,000 here and $6,000 there? How did she split that $22,000 loan up so that the interest earned was the interest charged was $910 after a year. So what we should do is write a little sentence that says we're going to let X be equal to the amount borrowed. Okay, and I'm just going to say at the 4%. So the amount that she borrows at 4%, I like to put that in the box. Then the remainder of that is going to be borrowed at 5.5%. Okay, so if X represents the amount borrowed at 4%, then, you know, you might say Y is equal to the amount borrowed at 5.5%. Okay. Now, we do know that she borrowed a total of $22,000. So, when we take X plus Y, the amount borrowed at 4 plus the amount borrowed at 5.5, that adds up to be $22,000. So, this Y quantity up here, we can find what that is in terms of a single variable X by subtracting X from both sides. So the amount borrowed at 5.5% is the total amount that was borrowed less the amount borrowed at 4%. So in the second box, I'm going to say the amount borrowed at 5.5% is the $22,000 less the amount borrowed at 4%. Now we need to remember how we compute the interest earned. Okay, so here the interest earned off of the 4% account is going to be the principal times the rate times the time of the 4% account. Okay? Now, so the expression that will represent the interest earned off the 4% account is the amount borrowed at 4% times the interest rate in decimal form, 0.04, times the time. Now, we know that that time is going to be 1 year because in our problem, that's what it said right up here, is after 1 year. All right? Now, let's write the expression for the interest earned off of the 5.5% account. Well, it's going to be the principal amount borrowed times the interest rate times the time. This time, the principal that was borrowed at 5.5% is the $22,000 minus X. We got that from right over here when we did the work from before. The interest rate is 0.055. The time is 1. Remember, interest earned at 4% plus the interest earned at 5.5%, I should be saying charged and not earned there, is $910. Let's clean this up a little bit and simplify this equation, and then we'll be ready to solve for X, which once again is the amount of money she borrowed at 4%. In this first term, I think it looks a little prettier if we have 0.04 times X. In this next term, we can simplify by distributing the 0.055 through to both of the terms in the quantity. So bring down the plus sign. 0.055 times 22,000 is 1,210 minus 0.055 times X is 0.055X, and bring down the equals 910. Okay, so next we're going to subtract 1,210 from both sides so that we can leave these variable terms on the left-hand side. And when we combine the 0.04x with the negative 0.055x, you get a negative 0.015x. Now, 910 minus 1210 is a negative 300. Solving for the variable x, divide both sides by negative 0.015. And so x is equal to negative 300 times negative 0.015 is a positive, crunch that into your calculator, 20,000. Now, we always want to label our answers for an application problem. The label would be the dollar sign, and I think we should also go ahead and say she borrowed $20,000 at 4% interest. So that means how much did she borrow at 5.5%? That was the y from up here, and so she's going to borrow the remainder, the 22,000 minus the x number. The 20,000 is what she borrowed at 4%. That leaves us with $2,000. Let me write that down here. $2,000 is what she borrowed at 5.5%. Now, our problem did ask us, if you go back and look at the top of your notes, how much did she borrow at each rate? $20,000 at 4%, $2,000 at 5.5%.